Okay, so what I'm going to do is try to go over, because I know this lab is a little bit difficult. I think the difficult part is trying to figure out what the graph is telling you, because even though they're giving you some information at the bottom here, right? They're giving you some information right here. They're not putting, they don't have numbers with the increments, and I think that's throwing you off. So let's look at this and figure out how to analyze what this graph is trying to tell you, and so that we can figure out what they're asking you to find in the question. So first of all, let's look what they're asking you to find. They're asking you to find what is the peak wavelength, right? So the peak wavelength, the peak is this right here. So this is what we're trying to find. This is our peak wavelength. And so we have to follow that down, right? We have to follow that down to the graph to see what increment that corresponds to. So let's look at these increments. So we see we have 10 very small increments here. Okay, we have 10 small increments. And then we have these longer increments. So we have 10 in between, or 9 in between, and then the longer ones mean 10. And if we look down here, it says this x-axis, the x-axis is giving you wavelength. And the wavelength is in nanometers. Whoops, let me erase that. The wavelength is in nanometers. I'm sorry, the wavelength is in micrometers. This mu right here, this Greek letter mu is micro. So that's micrometers. So that means that this long, let me show you again, this is a longer, this longer increment right here. This is 1 micrometer, or down here it tells you that 1 micrometer, sorry, 1 micrometer is equal to 1,000 nanometers. So that can also equal 1,000 nanometers. All right? So if this is true, each of these smaller increments equals 1/10 of a micrometer or micrometer, or 1/10 of a nanometer. So 1/10 of a nanometer, right, is 100, or 1/10 of 1,000 nanometers, sorry. 1/10 of a 1,000 nanometers would be 100. This would be either 100 nanometers or 0.1 micrometers, right? So now all we have to do is count these, because we're trying to figure out which one this one is. So if we see that this is halfway, right, between, it's about halfway, we know that if this is 1 micrometer, this halfway point is going to be 0.5 micrometers. It could also be, if it's halfway, it would be 500 nanometers, right? And since the answers don't give you, or there's no choice for 0.5 micrometers, there is a choice for 500 nanometers. Okay? Let's go to the next slide. So now this is asking for the range of wavelength for the visible spectrum. And so first of all, we need to know what the visible spectrum is. And this is going to be the spectrum of light that we can see, which is called the visible spectrum. So this is going to be our visible spectrum. And so if we remember down here, each of these, or this long, I have to remember our increments. This long increment is either it's either 1 micrometer, 1 micrometer, or 1,000 nanometers, right? Each of these smaller increments, again, are going to be 0.1 micrometer or 100 nanometers, right? So if we count, we have 0.1, 0.2, 0.3, 0.4 here, because this is where our visible spectrum is, right? We're going to follow this down right here, and we're going to follow this down right here. That didn't come out very good. So follow this down right here. And so from here to here is our visible spectrum. So we need to say, okay, so we want a range of wavelengths. And so our range is going to be 0.1, 0.2, 0.3, 0.4, 0.4 micrometers to 5, 6, 7, 0.7 micrometers, or if we're doing it in nanometers, this will be 400 nanometers to 700 nanometers. Okay, let's go on to the next slide. So this is the electromagnetic spectrum, and I saw that you had some problems with this too, so I want to go over how to read again the wavelength increments. And so it's asking you to put microwaves, X-rays, and radio waves in the order from lowest to highest frequency. But we don't see frequency down here, do we? We see wavelength. So what do we have to know? We have to know how wavelength relates to frequency. And so wavelength, a high wavelength or long wavelength would be something like this, right? This would be a long wavelength. A long wavelength, when wavelength is long or wavelength is high, our frequency, this is wavelength, our frequency decreases. So this would be a long wavelength or high wavelength and low frequency. Something like this is a low wavelength and a high frequency. Okay? So if we go across from gamma to the broadcast and wireless radio, we can see that wavelength is increasing, right? 10 to the negative 12th is much less. 10 to the negative 12th is much less than 10 to the third, right? 10 to the third is 300, right? 10 to the negative 12th is a very low number. So if this is a very low wavelength, right, this will be very high frequency. This would be low frequency at this end. Okay, so hopefully that helps you with that. Now it's also, on the next question, it asks you which one has about, let's see what it asks you here. It's asking you which of the objects emits radiation with a wavelength of approximately 0.01 meters. So now you have to know something about how to convert from, because we're not given meters here, we're given centimeters, right? We're given millimeters, and we're given feet. So 0.01 meter is equal to 1/100th of a meter, right? And 1/100th of a meter, we know that the prefix for that would be centimeter, 1 centimeter. So if you look, here's 1 centimeter right here. So if you go up, right? If you go up here, these are the ones. This would be one of the objects in this range that would have a wavelength of approximately 0.01 meters. Okay? All right, well, I hope this helps. If you have questions on this, please, email me or text me, and I'll get right back to you. Thanks.